Okay, we're on to Unit 2, and we're going to start with properties of exponents. Okay, these are really important. These will show up a lot throughout the semester. So, once again, we kind of want to work on that foundation. So, the first thing we're going to kind of take a note of right here is it says, note that if you have a negative value raised to some power p, that would be equal to if the base, that's known as your base right there, if your base were positive. So it doesn't make a difference if it's positive or negative if p is an even integer. So that only works as if this is an even integer. So for example, um, if I have, and we'll look at this one in a second, or actually I'll just go ahead and work it right here on the page. So if you look at a right here, you have negative 2 to the power of 2. Well, that's telling us to do negative 2 times negative 2. So negative times a negative is positive. And so you get positive 4. Well, that would be the same thing as if it were 2 to the power of 2. And so that's what this statement is implying right here, is it doesn't matter if your base is positive or negative if your exponent is an even value, because what will happen is even if the base is negative, a negative times a negative is positive, and so that's what's going to happen, is that it'll turn out being a positive. Now that's not true if it's odd. If it's odd, that does not hold, and we'll look at one of those in a moment. Okay, so let's see. Also, if you have negative n to the power of p, and you don't have parentheses around it, okay, so notice the difference. I don't have parentheses around this. That indicates that the negative is applied after the power occurs. Okay, and so we'll see some examples of that too in a moment. So let's see. Let's look at part B right here. So I have a negative 2 to the power of 3. So that's negative 2 times negative 2 times negative 2. And so I like to kind of do like a little upside down pyramid. So negative 2 times negative 2. So it does turn to a positive, but then see, I have to multiply it by negative 2 again, and that will leave me with a negative 8. So that would not be the case if I were to do a positive 2 to the third power. It'd be a positive times a positive times a positive, and that one would actually be a positive 8. So that's why this little rule over here doesn't hold. So looking at C right here, I have negative 2 to the power of 4. If I want to, I can just go ahead and write that as 2 to the power of 4. Because it's even, it doesn't matter if the base is positive or negative. It's up to you. I'll just go ahead and leave it negative so you can see that it does turn positive. But that'll just be something to kind of help you figure out your signs early on. So let's see, a negative times a negative, so that's a positive 4. Negative times a negative, that's a positive 4. 4 times 4 is 16. There we go. Okay, got a couple more for us to kind of get warmed up with the properties of exponents. So let's see, negative 2 to the 5th power. So let's see, negative 2 times negative 2 times negative 2. Let's see, oops, sorry. Okay, I cleaned that up a little bit. It's still a little messy, but anyway, still we can see those negative signs a little better. Okay, negative 2 times negative 2 is 4. Negative 2 times negative 2 is 4. And then times a negative 2. So 4 times 4 is 16. So we saw that from the previous example, but see, I'm multiplying by negative 2 one more time. So I end up with a negative 32 as my final result for part D. Okay, part E and F, we're going to kind of see this in action right here, where if we don't have parentheses around it, what's going on is the negative is actually really applied after the fact, okay? And so, just want to be careful about this. So let's see, really this is negative 1 times 2 to the power of 2. So negative 1 times 2 to the power of 2 is 2 times 2 is 4. Negative 1 times 4 is negative 4. Okay, F, really no different from E. So we're going to have negative 1 times 2 to the power of 3. And so you're going to have negative 1 times 2 times 2 times 2. And when you multiply that out, that'll turn into an 8 right there. And negative 1 times 8 is negative 8. Okay, so that's kind of, that's just looking at And you know, what is an exponent? It's just the power, and then the base is right there. So hopefully that kind of gets us started. Now we're going to kind of look at some rules that go with these. And so the first rule we're going to look at is the product rule. And so the way the product rule works is if you have x to the power of m times x to the power of n. So what I want you to notice is that the bases are the same. Okay, the bases have to be the same. Then what you can do is you just add the exponents together. So see, m and n got added together. And just remember, let's see, multiplication is commutative, and so that means we can move some stuff around. So we'll look at that property in a minute. That will be useful in a moment. And then just note that if you have a variable just sitting there like n or whatever x, it has an understood power of 1. Okay, and so we'll see that also in a moment. So starting with a right here, it says, okay, 2 to the third power times 2 to the second power. So using the product rule, what we're supposed to do here is add those exponents together. So this would become 2 to the power of 3 plus 2, which then become 2 to the power of 5 right there, okay? Do not do 2 times 2 and get a base of 4. Okay, that's not what's taking place here. Okay, so the product rule is pretty simple, and the best way to memorize it is to kind of actually just understand it. And so see what's going on here is 2 to the power of 3 is 2 times 2 times 2. And then you're multiplying that by 2 to the power of 2, which is 2 times 2. And so if you notice, you're multiplying the base 2 upon itself 1, 2, 3, 4, 5 times, and that's why it becomes to a power of 5 right there, to the power of 5. Okay? And so a lot of times we'll leave it like that. You could multiply it out and get 32 if you really want to. But right now we're trying to practice the product rule. And so that rule is that if you have the same base, when you multiply those common bases together, you add the exponents. Okay? So if you look at part B right here, we got x to the power of 4 times x. And so the second one doesn't have a power listed, but it's understood as a 1, so you can put it there if you like. And then using the product rule, what we're going to do here is you add the exponents together. So we're going to get x to the power of 5 right there. And that's it. And once again, just to really illustrate this, just to make sure we got this, see, x to the power of 4 gives you 4 x's, and then you have that extra x right there. And so exponents is just listing the common factor that's being multiplied upon itself how many times. So x times x times x times x times x 5 times, and that's what an exponent is. Okay, on part C, we're going to see the commutative property that I was speaking about earlier. And let me kind of show a little bit more detail on this question. So we have 4x squared times negative 3x to the fourth. So really, those are not attached to each other. They're getting multiplied together. So I'm going to kind of move them, give them a little space, okay? And then same thing over here. Then I have a times negative 3 and then times x to the fourth power. And so I'm going to use the commutative property to kind of clean this up and make it a little bit more user-friendly. And so what I'm going to do is I can move stuff around. That's what the commutative property is because 2 times 3 is the same thing as if I had 3 times 2, right? The order doesn't make a difference if you're multiplying a bunch of terms together. So what I'm going to do is I'm going to put the 4 times negative 3 next to each other. And then I'll put the x squared times x to the power of 4 next to each other. And now I can focus on each one individually. So 4 times negative 3 would give me a negative 12. And then here with the common bases, these are common bases, so then I can add the exponents. So that would become x to the power of 6. So negative 12, x to the power of 6. Okay. So we're going to look at I think about 3 more rules or so, and then what we'll do is we'll do a mixed bag of these. So our next rule is the power rule. And so I have that right here. So if you have a power raised to a power, you multiply those powers together. Okay, so I'm going to go ahead and do the property, and then we'll look at it a little bit closer so we can get a deeper understanding of it. And then we'll look at these other properties in a moment. So let's just start with our first one. So the power rule is that I take the powers and I'm going to multiply them together. So 3 times 2, I'm multiplying this 3 here and this 2 right here. And so I end up getting 2 to the power of 6. And I'm just going to leave it like that. Like I said, you could multiply it out if you like, but right now we're focusing on learning the power rule. So going back to the product rule, if you remember, if I had x squared, that's the same thing as x times x, right? That's the same thing as x times x. So see, look, I'm squaring 2 to the power of 3. So what that's really doing is telling me to do 2 to the power of 3 times 2 to the power of 3. And then you could do the product rule where you add them. So 3 plus 3 would be a 6, and you can see that's our answer that we have right there. Okay, so hopefully that kind of makes it a little bit more understandable of why do we multiply, right? It's the rule, but why is that the rule? And so hopefully that helps out a little bit right there. Okay, on the next one, we're going to do the power rule, but we want to use this part of the rule. And the power rule, basically, if you have a parentheses around something, everybody's invited to the party inside the parentheses. Basically, everybody inside the parentheses is going to get multiplied by that power. All their exponents get multiplied by this power right here. And the same is true if it's a fraction. So everything inside the parentheses would receive that power. So what I'm going to have to do here is this 3 will get raised to the power of 3, and so will the x to the power of 4 will also get raised to the power of 3. Okay? So that's what we're looking at here. So 3 to the power of 3, I'm going to have to do 3 times 3 times 3. And then here, the power rule is I multiply that together, so that should give me an x to the power of 12 when I multiply the 4 and the 3 together. Now here, let's see, 3 times 3 is 9, and then 9 times 3 is 27. And then I have x to the power of 12, and there we are. Okay, let's look at C now. So I have 2 over x raised to a power of 3. So I'm going to raise both of those to a power of 3. So on top, I have 2 times 2 times 2. And on bottom, I have the same thing, x times x times x, but we'll just leave it as x cubed, right? And let's see, 2 times 2 is 4. 4 times 2 is 8. So I end up with 8 over x to the power of 3. Okay, so all these rules, I mean, they're fairly simple, but they do take practice. And the more you kind of can develop an understanding of why the rule is that way, the less likely you're going to mix them up. Because they're all pretty simple, but eventually we're going to mix them together. Like you'll have a problem where you might have to use 2 or 3 different rules on the same problem. So just kind of keep that in mind. Okay, negative exponents. This one's kind of weird. And this is going to be one that will take time to kind of get a better understanding of why it works the way it works. So for now, you'll kind of have to take my word at it. But as we get further into this topic, we can kind of discuss it on a little bit of a deeper level. But for right now, the way you want to kind of think about negative exponents is you just take the reciprocal and it causes your exponent to turn positive. So if you had, some base raised to a negative power, you flip it, and then the exponent changes from a negative to a positive. And if you were to flip it the other way, if I had, let's say, a to the power of n and it was positive, and I flip it underneath, well, then it would become negative, right? So whenever you take the reciprocal, whenever you flip a base, either from top to on bottom or from bottom to top, it's going to change the sign of the exponent. Like I said, it's probably kind of weird, like why does that happen? And that's kind of, I can't really just explain it right now with these problems, but as we get further into it, we can talk about it on a deeper level. And so you can see if if my base is in the denominator spot, I can flip it to where it's on top, and the exponent became positive, right? And then if I have a fraction, you can just take the reciprocal of it. A over B would become B over A, and then the exponent would become positive. So we don't really like to have negative exponents. So a lot of the times, if you're given a problem with negative exponents, sometimes you're just asked to make sure all the exponents are positive. And so that's what we're going to focus on here. So on part A right here, so I have a negative exponent, and it's basically understood that it's over 1, because dividing by 1 doesn't really change anything, right? And so what I'm going to do is I'm going to go ahead and flip it. And let me kind of show you this. You could also kind of ideally think as you have a times 1 in front, right? And that doesn't change anything. Multiplying by 1 or dividing by 1 does not change anything. You can multiply, divide by 1, nothing changes. But I want to fix my negative exponent, so this is all going to flip underneath. So now it's going to be 1 over 3 to the power of 2. And I don't really need that understood times 1 in front anymore. It's just kind of there to kind of give us a little bit better understanding of how it flips. And so then now 1 over 3 squared, if you wanted to leave it like that, that's okay. That's a pretty small number though, so I'm going to go ahead and finish it off. So that would become 1 over 9, because 3 times 3 is 9. And there we go. That's it. That's part A. That's it. So don't overthink this. Like I said, as we get further into this, we can kind of discuss where this rule kind of comes from. When we get to the zero exponent rule, that will help some. Okay, our next problem, a lot of times students, what they'll do is they'll say, oh, the answer is 3x to the power of 3. That's a very common misconception on this problem, but that is not correct. What you have to realize here on part B is that 3 is not actually attached to the x to the negative 3 power right there. They're not attached to each other. That 3 has an understood power of 1, which is positive. So there's nothing wrong with that 3 right there. But we do want to fix this. So this guy's going to flip to the top, and now his exponent becomes positive. And then on bottom, that 3 is going to stay there. And that 1, I mean, you could put a 1 right there, but times 1 is not going to change anything. So we typically don't worry about putting the understood 1. Okay, part C right here. So I have a negative exponent and I have a fraction. So we're going to apply this rule here where we're going to swap it. The x goes to the top, the 2 goes to the bottom, and then now my power is a positive 2. Now I need to square both of these. So on top, x squared is, well, x squared. And then on bottom, 2 squared would become 4. 2 times 2 is 4. Okay. So now we're going to look at the quotient rule. All right, so the quotient rule is actually very similar to the product rule. Like, you'll see the connection with the product rule in a second. So whenever you have a quotient and the bases have to be the same, you're going to subtract the bottom exponent from the top exponent. So you're going to bring this together with one single base. So remember the product rule, if you had x to the power n times x to the power m, we added them, right? We added them. Well, if you're going to divide them, then you're going to subtract. Okay, and so the denominator exponent always subtracts from the numerator exponent. Then we have the zero exponent rule, and this one's, once again, it's kind of interesting, but it actually kind of connects with the negative exponent rule up here, and we can talk about that a little bit. I don't want to go too far off on that because I'll just end up confusing more than I'll be helping. But n to the power of, so if you have a base raised to a power of 0, as long as the base is not 0, it equals 1. So for example, like 10 to the power of 0, that equals 1. Let's see, 0.3 to the power of 0, that equals 1. Okay, as long as I don't have 0 to the power of 0, and I'm never going to throw that one at you, but that's just kind of fine print that you can't have a zero base to a zero power. Okay, so simplify and give your answers with only positive exponents. So that's something I kind of mentioned earlier. We only want to deal with positive exponents. So following the quotient rule in part A, so I have a base 2 to the power of 5 divided by base 2 to a power of 3. So the base is 2, and then I'm going to take the top exponent and then subtract the bottom exponent from it. And that's going to give me 2 to the power of 2. And then 2 to the power of 2 is just 2 times 2, which is 4. So I'll go ahead and multiply that out. Okay, on part B, let's see. I've got 2 to the power of 3 divided by 2 to the power of 5. So this time I have to subtract the 5. And so I end up getting 2 to the power of -2. But it said only positive exponents. So I'm going to have to use the rule I learned from up above, where I'm gonna flip the base 2 down below, and its exponent will become positive. And so there's an understood times 1 on top. Okay, you don't need to write that every time, but just to kind of make sure I'm not losing anybody. So this 1 times anything, you get the same thing in return. So that 1 will stay up there. And then this 2 is going to come down below, and its exponent becomes positive. And then you have that, times 1. That's not going to change anything. And then 1 over 2 times 2 is 4. So this would be 1/4 right there. Okay, and then part C, okay, so how can a power of 0 make it equal 1? Well, this kind of will help us give a little better understanding of that. Hopefully we know that 2 to the third power is 8. 2 to the third power is 8. 8 divided by 8 is 1, right? But let's see this doing the quotient rule and then our 0 exponent rule. So this should be 2 to the power of 3 take away 3, right? Numerator, subtract the denominator power. And so I end up getting 2 to the power of 0. So any base, as long as it's not 0, will give me a 1. And that's where I get my 1 right there. Okay? All right. So just to take a little bit more of a deeper dive on this real quick, let me show you another way of kind of looking at this. So if you look right here, 2 to the power of 5, that's 2 times 2 times 2 times 2 times 2, right? It's 2 multiplied together 5 times. And then on bottom, I have 2 to the third power, which is 2 times 2 times 2. And so if you look right here, you can be like, okay, that 2 cancels with that 2. Here, 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 here. And so on top, that leaves me with 2 times 2, which is 4, which we saw that was our answer from earlier. Same thing with part B. If I were to look at this as 2 times 2 times 2 over 2 times 2 times 2 times 2. And so what happens here, the 2's cancel here, here, here. And what happens is when they cancel, really 2 divided by 2 turns into 1 over 1. 1 over 1. 1 over 1. So on top, you're left with 1 times 1 times 1, which gives you the 1 right here. And then 2 times 2, and then times those 1s right here, which don't really make a difference. That gives you the 4 on bottom. So just to kind of take a little bit of a deeper dive on this. Okay, so like I said, all the rules, they're not super challenging. The one that, like I said, that throws people off the most is kind of the negative exponent rule. The 0 exponent rule kind of throws students off too, but that's very simple to remember. Just 1, 1, 1, 1. If the power is 0, 1, right? The negative exponents, that's a little bit trickier. And to be honest, that's something that, if you are going to major in math, it's something that you'll look at in some of your courses that you'll take at your junior level. And so for now, I wouldn't worry too much about it. I would just try to remember these rules that we went over. Just remember negative exponents. To fix that, you'll do the reciprocal, okay? And if you do want to kind of talk more about this, I'd be more than happy to meet up on Zoom. But for now, I really wouldn't worry too much about it. We're going to have other things we probably need to be concerned with. But anyways, I'm going to go ahead and stop here, and I'll start a part 2 for this section of notes.